In the dormitory, make a super explosive jet car. The method is simple. The key is to steal a good classmate's thermos, discard the lid and spout, draw a small circle on the bottom screen, place it on the counter, and directly start the stove with a foot mold machine. Gather on the left, gather on the right. I went, and it turned out to have a double bottom. I didn't get it through. Hey, continue to mark the line. Continue like this, that's right. Finally, it's clear. Use a caliper to measure the inner diameter. Drink the beverage left behind to just have the can. Measure the outer diameter. Hey, it's just a little smaller than the thermos. Draw some tiny stars on paper to perfectly cover the small jar. Drill holes according to the marked positions. There are quite a few holes. Take it slow. Use the grinder to expand the bottom position. In no time, it's all done. This way you can peel off the external positioning. Stick a circular positioning paper at the bottom of the can. Poke small holes according to the star map. Well, this indeed looks a bit shabby. Mark a point on the thermos and drill through from all sides. Use a marker to go through the small holes on the small can to mark the positions. Continue drilling holes in those spots on the can. Don't miss any of the 4 holes. Place it in the thermos flask and secure the can with your company's tool. The jet barrel part is completed. The dormitory conditions are limited, so the workmanship is a bit rough. Next, cut a piece of 306 stainless steel square plate. Use a compass to draw a circle with a diameter of 8 centimeters, and then another with 3 centimeters. Visually divide it into 18 segments. Use nail clippers for pedicure to cut out the circles. Continue cutting along the seam, being careful not to cut through. This is the prototype of the engine turbine blades. Drill a hole in the center, and use tweezers to adjust the angle and direction of the blades. Just a gentle bend will do. Use the same technique to make 2 more pieces. Cut a screw rod with a diameter of 10 millimeters, mark at 6 centimeters, use an angle grinder to cut it off, mark one end, clamp it on the platform and start drilling. This is certainly a skillful task that even the master might not manage. This hole is drilled quite nicely. Grab some nuts and washers, and then install the 3 turbine blades one by one on the screw rod, separating them with threads and washers in between each blade. Each turbine must be secured firmly, then give it a spin, and watch it fly. Use a piece of preset wooden board as the base, place the insulated cup in the middle, hold it with 2 wooden blocks, and glue it to the base, fitting it with a suitably sized wall. The self-locking screw is secured onto the wooden block. Remember to drive it in a bit deeper. After 2.5 points, give the glue a shake to ensure it won't come off. Find a high-speed brushless motor from the trash bin, apply some glue to the center of the impeller, and insert the shaft into the screw hole to secure it. The screws secure the motor to the wooden baseboard. After tightening the 4 screws, gradually insert the turbine blade into the thermos cup. Hey, the height is just right. Fix the motor base with glue. Next, we'll start on the circuit part. Add a brushless electronic speed controller. Go straight up with the wire to avoid cold soldering, so you can safely solder the brushless motor. Finally, wrap it well with insulating tape, drill a hole at the center of the thermos, and insert a hollow 4-3 inside. Remember to leave a small tip outside. A section of high-pressure rubber tubing, firmly push one end into the screw rod. Connect the brushless speed controller, then insert the battery. Let's test the motor's operation. Not bad. Not bad. The motor spins really fast. Although it looks a bit off axis, such minor issues can be ignored. A bottle of high-purity refrigerant. This stuff is what is used for refrigerators. Connect it with the high-pressure rubber hose. Next, we will conduct the engine ignition test. Open the fuel chamber and start the motor. Don't cry. Testing the firepower count when no engine is selected. Old guy almost left the table, and he ran off. Next, assemble the drivetrain. The nephew's toy car was taken apart to install 4 small wheels on the baseboard. Finally, fix the fuel room, control room, and power supply unit securely, and our jet propulsion car is perfectly ready. What do you think? Awesome, right? Let's hit the hallway and show it off. The power is all normal. The fuel chamber connection is normal. The engine startup is normal. Everything is normal, beginning to increase thrust. What do you think of this little guy? Have you fallen in love?